I am the entire event MC.
Oh, okay.
Yeah, so they got. Oh wait.
Yeah, you just hit live. I'm like, I'm gonna
I
use the
did go
restroom.
live. I
Sit
guess
down
we're
for
live
now.
now.
Okay. Well, in that case, Joel, I'm gonna take a quick bio break. I'll be right back.
Yeah, go for it. I'm gonna host some people here. Apparently, I hit a button. Hey, everybody. I guess we went. I guess we went live pretty quick there. How's everybody doing? Get some people in here. We're gonna be talking. Well, here we're gonna be talking PCTG with John at 3D-Fuel. Hey everybody. This is gonna be cool. We're gonna and we've got PCTG printing right there on the H2S. Yeah, we're live. That was an accident, but you know what? It was a happy accident. It was a Bob Ross style accident. Because yeah, that's what happened. Yeah. War Paint and Unicorns, hello, right back to you. TJL, hello. Jerry, yeah, we are live. What's up? Hobby Main, what's up, everybody? What's up? How's it going? It's Unique Prince. How's it going? It's going well. I appreciate you asking. Okay, John's back. John, I'm just going to bring you into the fire right here because welcome to the show.
Hey, thanks, Joel. Good to be here.
So everybody, this is John from 3D-Fuel. And if John looks familiar, it's because we had a really cool episode of the show where we talked PCTG from Rapid, right?
Yep, that was at Rapid this year.
And a lot of people really loved it, watched it, and wanted to know more. So John and I have been scheming to put together some sort of little live stream here. We can talk PCTG.
Yeah, it is. It's one of the materials that people get really excited about once they learn more about it, but there's a lot of confusion around the material too, because
really,
the PC and PCTG people, understandably they're like, oh, polycarbonate, but what is this TG part of it? And it's like, oh no, it's more related to PETG than it is to polycarbonate. So yeah, I mean, there's just.
Well, we talked about that in our video that we did, right? The PC is not polycarbonate.
Right. It's a very long chemical name.
Polycyclohexylene. No, polycyclo.
No, you're on the right track.
A polycyclohexylene, but there's something. It's like polycyclohexylene something terephthalic glycol.
Polycyclohexylene dimethylene.
Dimethylene, that's what I forgot. Yeah. Polycyclohexylene dimethylene terephthalate glycol.
Yeah, it's just spell it as it sounds.
Well, now, okay, so here, I want to show people what's going on right here because here, John, you're still in, but obviously I just wanted to show people that beautiful print that's going down. So this is which material? This is ruby red, is that right?
Yep, that is the transparent ruby red PRO PCTG.
It's beautiful.
Yeah, and it prints great on the Bambu Lab printers. They do a really, really nice job. That looks like it's the H2S.
That's right. This is the H2S. And I like that what Bambu did is they added that PCTG preset where you just be like, hey, yeah, it's just generic PCTG. Let's go.
Yeah. Is that the profile that you're using right now?
Yeah, it's just generic PCTG.
Well, what's cool about that is once we have our hands on an H2S, we'll be able to get a profile that is even better than that already good profile.
Wow.
Yeah.
What's stopping you?
Right now, honestly, I'm so busy getting additional production lines commissioned and installed in our facility, and then getting ready for 3D Printopia. We have one on the way; it just hasn't arrived yet. And I mean, it'll be quick to do a profile. It'll be different than the H2D, but not so different. But I mean, there are little things like the flow rate calibration and getting the pressure advance stuff all set up on a particular printer, and then retraction, not the retraction itself so much as it is the wipe settings, just to help make sure that you keep things like stringing under control.
Sure. Well, what's really great when you have the machine and the software, you can do the calibration. And that's like the unicorn of 3D printing is when a manufacturer gives you profiles for the software in the machine that you have in order to get beautiful prints. I just want to call out Bearded Printer here. Maybe I should try PCTG. What do you think, John?
I think he should. I think he definitely should try it out. And Joel, I think there's an even better way for him to try it out, given that we're doing the live stream today.
Oh, right. Yeah, there's a link in the description, Bearded Printer. It's 10% off.
Yeah.
Yeah, sweet. Here we go. Well, let's intro it. One solid cube. What is PCTG? All right, John, the floor is yours. What is PCTG?
If you're familiar with PETG, it's in the same copolyester family. So it's like the souped up, overpowered cousin of PETG. One of the big reasons that it is, what differentiates PCTG from PETG is the ratio of something called CHDM. I believe
CHDM.
Yeah. So Joel, that's the cyclohexylene dimethylene. I think it's cyclohexylane, but and I know that there's going to be some chemistry and polymer scientist people out there that are going to be cringing in the way that I said that, and that there's a major difference, I'm sure, between what those two things are.
I'm sure there is, but currently that is the cyclohexylene dimethylene.
Yep. Okay. And that's what lends it so much more impact toughness, better chemical resistance, and not only just stronger chemical resistance, but broader chemical resistance. And I believe it also contributes to its, to its greater UV resistance. There's about 5 degrees Celsius better higher temperature resistance. And it is also, I can't remember if I said it's more UV resistant. Oh no, it absorbs moisture at 1/3 the rate.
Well, a lot of people speak to ASA for UV resistance, right? And that actually leads me to Ted's question here. Maybe this was already covered. It wasn't, but how does PCTG compare to PLA, ABS, and PETG? So let's just start with at PLA.
Right.
PCTG compared to PLA is it is more ductile.
Yep.
It can withstand higher temperatures.
Well, and Joel, on the ductile part, someone on that video that we did at Rapid made a very important distinction between ductile and compliant. Where ductile is if you bend it and it stays where you bend it, and compliant is where you bend it and it goes back.
Really?
I believe. I know that someone corrected us, and I'm like, that didn't feel right, but they were absolutely correct. And we were wrong. Yeah.
Interesting. Okay. So whether it's ductile or whether it's compliant, it is one of those things. And PLA is very rigid and brittle.
Yep, that's correct.
John, did you forget to plug in your camera?
Let me check.
Lumix shut down now. Everybody put an F in the chat for John's camera. I should get an Oregon Trail GIF, and every time that happens, just "you have died of dysentery." Come on, John. John, we're waiting, man. Look at that. That is John over there. Well, at least I got some sweet prints going. Look at that. That's that ruby red PCTG. So let's see. While John's away, let's see if I can cover it. PLA being more rigid, more brittle, and a lower glass transition temperature compared to ABS. That one is going to be interesting. I'm going to have to wait for John on that one. But as far as PETG goes, imagine PCTG as the stronger, more resilient, tougher cousin, I believe.
Yeah. So Joel, we're doing an audible here, and we're switching from one camera to another. It was plugged in, but for some reason it is just not.
Look at that. We get to see more of your place.
Yes. Yeah. Okay. Yeah. I'm doing this here because the production facility is quite a bit louder than my apartment is.
We'll visit there sometime, right?
Yeah. Yeah. For sure.
Sweet. Okay. So we covered PLA, right? Yep. PLA is more rigid. It has a lower glass transition temperature. It doesn't have UV resistance. It's a simpler material. PLA is, right?
Yep. And PLA is a corn-based plastic. So that's going to be, that's also kind of an important distinction. So PLA, when you're printing with it, tends to have that kind of sweet kind of corn syrup smell to it. Yeah.
I like corn.
And then comparing it.
I'm sorry. Go ahead.
Oh, I was going to say, yeah. Then comparing it to ABS, I would say that it is different to print with than ABS is. You don't run into the same type of warping or kind of a requirement for an enclosure as you do when you're printing ABS.
I believe you have the door open on the H2S and it's printing just fine.
And I think that I know that the VOC output of PCTG is much lower than
Okay.
ABS, and I believe it's even lower than the VOC output that you have from PETG.
What
So
about the mechanical properties though?
yeah, so mechanical properties, your impact toughness is going to be, I believe it's going to be better. It can definitely take more of a beating. It's going to be less stiff compared to ABS.
Really?
And yeah, I forget what the exact values are, but if you're taking an ABS printed part, let's say something in a simple vase mode, and I'm regretting that I don't have a simple vase mode print here to be able to demonstrate this, but the PCTG, you're able to basically completely squeeze it closed and it'll bounce back.
Yeah,
ABS, you can't really do that to that same degree.
that's true.
Yeah.
Huh. Well then, okay. So in that, I know that Ted didn't mention TPU or TPE here, but with the compliant ability of PCTG to, in like a vase mode, like you said, fully close and bounce back, TPU also has that. But again, it's a different polymer. I get it, but
Mhm.
where is the difference in the polymer that allows PCTG to be rigid but compliant and TPE TPU to be different?
Um, a lot of it just comes down to, like you said, the chemical, the polymer differences. And if you're familiar with the shore hardness scales, you have your
Mhm.
shore A. So when people think of like a really flexible material, they're thinking of like a 98A shore hardness or a
Yeah.
95A shore hardness. And if numbers being the same, shore A is going to be softer or more flexible than shore D is going to be. Most 3D printers, even direct drive, I
Oh,
mean, like your lower limit in terms of the softest you can print is like the low shore, like shore 90A. And there are some printers that can do like a shore 80A, and I forget what the name of the company is, but there's a filament manufacturer out there that specializes in that really soft shore 80A material.
really? Okay.
And then if you think about some of the, like a harder durometer material, I mean, we've done a durometer test with Pro PCTG, and it's about a 76D. So think almost more
Oh,
like a hard hat material.
okay.
Yeah.
Almost like forgiving is a
Yes,
good way to
for,
describe it then.
forgiving, but it won't. You're able to do a lot of really cool things by varying the thickness of the 3D printed part, because it will be very it's just very durable. I mean, it's durable
Cool.
without like catching things in it. If you think about like hitting let's say you print a ball in like a soft TPU, and you were I don't know, hitting it with a sandblaster, a lot of that sand is going to embed itself into the softer TPU material, because it's able to, it's softer, it's more compliant, and so it's going to, or more ductile, it won't be able to resist that type of force in the same way. It won't be destroyed, but it won't give way to something harder being thrown at it.
I see. That kind of makes sense though. And I like that about the material. There was a comment that someone brought up, and I'm not trying to call out another manufacturer, but it says tried a different PCTG. It was junk. 3D Fuel looks better. So in that, how different, like I know that we have PLA plus, tough PLA, HT PLA, varying colors, varying mechanical properties. Is PCTG similar in that there's just a varied scale of what's available quality wise?
Yeah, absolutely. And this is something that we're dealing with right now, that there are filaments out there that are calling themselves PCTG, and they may technically be PCTG, but I don't think there is a definition of the ratio of CHDM that makes a material PETG versus PCTG. For example, I know there's a couple other manufacturers in the US of PCTG, but when you look at their data sheets, and one really telling piece of the data sheet is the material density, or the specific gravity. And CHDM has a density of about 1.02, and so most PETGs have a density of 1.27.
Yeah.
PCTG has a density of 1.23. And the reason that like our PCTG is a density of 1.23 is because that higher ratio of CHDM in the material in the PCTG we use drags down that overall density
Huh.
relative to a PETG.
Is there a way to test, like if I had a spool in front of me, is there a way to test for such a minuscule density difference? Like think of me as a consumer. Like, can I chew on it? Can I lick it? Can I look at it under a microscope? Is there a way for me to test the density of a material just to verify?
That makes me think of the Rudolph the Red-Nosed Reindeer movie, the old claymation one, where you've got
Sure.
Unicorn Cornelius biting the, he's hitting with his pickaxe, and he's trying to figure out if something is real silver. It's not to say that there isn't, but I can't say that there's anything that I've tried where,
Okay.
I mean, I've never really tested it to try and determine that. I mean, you could always send it off to a lab to do some analysis.
That sounds expensive, John.
Yeah, I don't think there's a really good like at-home way to be able to tell the difference.
Huh.
So,
well, maybe that's something that you and I can work on. It would be really interesting because as PCTG gets more popular, it's not just going to be you and these few others that offer it, is my guess. And if we can find a way, because like with PLAs now, you can extrude a certain amount or print a certain model, or there's all sorts of ways to verify what you have and kind of get a feel for the properties. But maybe you and I can come up with something for PCTG.
Yeah, that would be really interesting, because some of the PCTGs that are out there, when you look at the data sheets, I mean, it's closer to a really nice PETG than it is to a true PCTG.
Okay.
But I mean, this kind of goes back to your point about PLA. There are so many different manufacturers of PLA out there that while something is technically PLA, it's, what kind of PLA is it? If it's a silk PLA, odds are good that it has either some sort of TPU as the silk agent, or it has like a polyethylene. Those are usually the less expensive silk PLAs. Then you have your matte PLAs. You have and
PLA Plus, HD PLA.
Exactly. Yeah. I mean, we're not immune to that either. I mean, we have something called standard PLA Plus, and even that was something that changed over the years. When we first came out with our PLA filament in 2015, we just called it PLA, and then other companies were coming out with PLA Plus, but their PLA Plus just meant that there weren't additives or fillers in it, and so we renamed ours to be called PLA Plus, so it was more of an apples to apples comparison. I mean, we haven't changed our standard PLA formula since 2014. I mean, we're pretty open about what it is.
Jeez.
And then we also have a tough PLA too. And tough PLA, for us, it's more popular than the standard PLA is, but that's one that we get directly from NatureWorks. It's and we're open about it. It's their 3D-870 resin, but that one they have an impact modifier compounded into it. So that's how that's how that kind of achieves that tough PLA effect.
That's cool. I mean, that's interesting, right? That additive gives you. I worked with like Protopasta, friends of ours, and they have some modifiers, and we've tested them within the filaments, and it's just it's neat having so many choices for the specific applications that you have.
Right.
I want to bring up this comment by Matthew. There's 3 of them left. So Matthew bought a roll of your PCTG printed with the default Bambu PCTG settings, which is what I'm doing. He says he was unimpressed and he dropped a part and it shattered. And so
I know why.
Oh, okay. Matthew, I hope you're still there. I know this comment is a little older. Well, John, why did it shatter?
It shattered because the Bambu's default PCTG setting has the hot end too cold, and it's too cold for the speed at which it's being printed, and so there's not enough thermal energy. So here's a really big difference between PETG and PCTG. PETG, you want to have a lot more cooling, right?
Yeah.
PCTG, you actually want to have less cooling. If you do have an enclosure, while you don't need to, it's not required that you have an enclosure, but PCTG benefits from having an enclosure. And one of the other differences in a PETG versus PCTG profile, or a good PCTG profile, is you want your cooling fans for PCTG turned down as low as you possibly can. You want there to be as much thermal energy transfer from one layer to the next, and that's going to improve that layer to layer bonding.
Is there an upper limit at the temperature at which you can extrude PCTG and still maintain the mechanical properties that you want?
Yes. And this is a bit of a complicated answer to what seems like a straightforward question. It depends on the speed that you're printing it at. And this is, I think, one of the reasons why PCTG has not become more popular as a material prior to the last couple of years is it is very possible to at the same temperature that you're printing one part of your print, be printing too hot if you're printing too slowly. So with too much,
Oh.
right. So there's a narrower window,
Oh.
there's a narrower temperature window for PCTG to get your optimal mechanical properties than there is for PETG. So for example, if you're printing PCTG too cold, then you will have a matte finish to it. So if you're getting a matte finish on a PCTG part, unless it's a dedicated matte formula, it means that you're printing too cold. So you're already going to have a weaker part. But if you're printing too slow and or too hot for the speed, for the volumetric output that you have, then it will actually start to degrade and you'll start seeing air bubbles in your print. And that can also lead to a weakened part. Now, this is something that we really we really discovered with high flow nozzles, because so many of them end up splitting the flow of the polymer on the inside of the nozzle.
Right. Yeah, there's that shape. Those three
exactly like
pathways
the
that kind of
that style of nozzle. And when you split the polymer stream like that, you need a lower effective hot end temperature to achieve the same mechanical print results. So for example, on our Prusa Mark 4S, which when we were developing the profile, we were a little surprised by this. We could not figure out how to get the oozing under control at first. And we're like, it can't be temperature. It can't be temperature. But when it turned out to be temperature. So most of our recommendations state that you want to be printing at 250 to 270 degrees Celsius on the hot end. But what we found is on the Mark 4S with the high flow nozzle, if you're printing something like a Benchy or printing something in vase mode, you get better results going down to like 240 or 245.
Really?
And
wow.
This was really apparent on a material or on a color like our transparent colors, where you can see the bubbles more readily, because we'd see in some parts of the print there would be air bubbles in the finished print, and then in other parts there weren't. And one of the other cooling settings that you need to change is you need to increase your minimum print speed when you are slowing down layers to achieve a minimum layer time. So if you have and again, this is why a good profile from
this
from the
really speaks to having a good profile.
Yeah. For example, on a lot of the default profiles that we saw, it had a minimum print speed of 10 millimeters per second. Mm-hmm. And so what you would run into is if you were printing, let's say you're printing on an H2D or an H2S, and you're trying to really print fast, you're trying to move a lot of volume. That's great until you get to a small detailed part on that print, and then you start getting poor print results in that area. Or the opposite is true. You're getting good results in the fine detailed part, but you're getting a matte finish, which means a weaker part in the larger areas of the print where you're moving faster.
Okay.
So
wow. Okay, well, let's summarize this a bit, because I want to get some good information to Matthew. I hope he's still here. So then can he reach out maybe for some settings advice for the machine that he's running? He said default Bambu, but we talked about some, but anybody that has an issue, they can reach out, right?
Yeah, they can reach out, sales@3dfuel.com. That creates a ticket in our support system. The other thing I would really recommend to him is to go to the 3D-Fuel website and download one of our profiles for the Bambu Lab printers. So we have a profile for every Bambu printer, with the exception of the H2S. We just haven't gotten to the point of developing an H2S profile yet. So
it should be really similar to the H2D.
Yeah.
Yeah. Here we go. Josh is asking, so PET is much better than PETG. So then would PCT be better than PCTG?
That's a really good question. I've never printed with PCT, so I can't say one way or the other that it is or isn't.
I've always heard glycol makes the printability better, right?
That's exactly it. So it depends on what someone means when they say better. In terms of like mechanical performance and stiffness, I'm sure PET probably is the superior material. But in terms of keeping warp under control, especially on larger parts, I think PET is a more challenging material to print. But like we've seen with materials like polypropylene that were very, very challenging to print 4 or 5 years ago, printers are getting so much better now. Print surfaces are getting so much better now. Even slicers, like for example, PCTG really benefits from having your pressure advance setting dialed in. A K value that's incorrect is going to, or that's too far from what it should be is you'll see the print different, or the print result differences between one K value to the other.
Wow.
And what we've seen is, you know, for a lot of PLAs on a Bambu printer, your K value is around 0.02. For
I've seen that, yeah.
for PCTG, it's more like 0.06. So it's,
Oh,
you know, it's a fair bit higher than PLA.
It's a very minuscule change, but it can make all the difference in the world.
But there have been some printers that we've developed profiles for where the K value is closer. I think it's to like 0.13, 0.15. I haven't had someone.
Wow.
I had someone very angrily that has a FlashForge 85M Pro say, "Hey, this is, you know, your K value. There's no way that that's right." And like, well, try printing with. Have you tried printing with the profile, or did you just look at the profile? And they tried printing with the profile, and they said, "Okay, yep, I was incorrect on this particular printer and this particular material. That is the correct setting."
That's amazing.
But that's also why we don't develop profiles on printers unless we have them in front of us, because you can develop a theoretical profile, but the reality of the hardware is going to be, it's going to be different than what you think it's going to be in theory.
Yep. Well, because if you don't have it in front of you, the only specs you have to go from are the marketing specs, which may or may not be fudged a little bit. Tactical Printing is saying, how do you dry PCTG and does it need a lot of drying? And if I remember correctly from our conversations, it doesn't need a lot of drying, right?
Unless it's absorbed moisture. So, and I'm sorry for the truck sounds outside my building right now, but
I don't hear anything.
It's fine. It's just me. So PCTG will absorb moisture over time. It just absorbs it more slowly than PETG does. So when you do need to dry PCTG, we recommend 65 degrees Celsius for 6 to 12 hours. And that kind of wide range for the amount of time, it just depends on how much moisture it's absorbed.
Okay.
And it can be impacted by what the humidity is in the environment that it's being dried. And I mean, not all filament dryers are made equally. Like when we're
the truth, that's the absolute truth.
When we're making the filament in our facility, we dry our resin in a desiccant wheel dryer. So think of desiccant that is continuously being being recharged. Yeah. So you have hot air blowing through one part of it as it's continuously rotating, that recharges the desiccant, dries it out. And then you have the air that runs through the hopper for the plastic pellets, and that's running through the desiccant that has just been dried. So it's perfectly dried desiccant.
Wow.
And we dry it at 65 degrees Celsius for 4 to 6 hours. And but that's with very, very dry air that's running through it. So
yeah, you are in a very arid environment.
Yes, exactly.
One of the things that I do with like Peak and Ultim is I heat it, but then I put it in under a vacuum for a bit. Okay. So would PCTG benefit from a vacuum when attempting to dry it?
Yeah, I do not think it would hurt it. Yeah, because getting that, pulling that vacuum, that you're pulling pretty much the entire atmosphere out of that area. So that's getting all of that moisture out as well.
Okay. Yeah, I guess anything, it wouldn't hurt it. That's a really good point. It's like, hey, anything you can do to remove the moisture, you could cut the amount of time it takes to dry it.
Right. Yeah.
Yeah.
I think that's a fair assumption.
George is asking, I have an Anycubic Cobra S1. Am I going to need anything special to print PCTG? And I want to think that the answer is no.
Correct. It should be no. And we actually have a profile for the Anycubic Cobra S1, but I did have a customer reach out to me, and Joel, maybe you know the answer to this, but they said that their Anycubic Cobra S1 had a PTFE lined hot end, which I didn't think they had. I thought that it was an all metal hot end since it goes up to 320C.
Yeah, I thought it was as well, but I haven't taken mine apart to verify. And something like that sort of anecdotal sort of information, I don't think someone's going to make that up.
Right. Yeah. So I don't want
after the stream, I'll go take mine apart. It's just right over there.
Right. I don't want to tell a customer that they're wrong, but basically if your hot end can get up to 260, you should be able to print with PCTG. If it's for something that we don't have a profile for yet, I can't guarantee what the results are going to be because it can take a little bit of time to get a profile dialed in. But I mean, we've printed it on our Anycubic Cobra S1. We have a profile available on our website. So you should just be able to download that and import it into your slicer and then be ready to go.
Huh. Well, I mean, I think that's kind of the story that we need to tell here, is that when people have questions about PCTG, I mean, obviously information like this from you is really valuable, but at the same time, you offer a lot of stuff on your website to get whatever printer they have going with it. They don't need to have a Bambu lab machine. They can have their Anycubic and get good results from it. And you have an S1 profile, and how were the results? Do you remember? Did it look pretty good?
Yeah, I mean, I think it was pretty good. I know that with the Anycubic Cobra that we have in the shop right now, we're running into some dimensional accuracy consistency, but
Okay.
we're not sure. But that's not tied to the material itself. We're running into that on PLA as well. So I don't think it could just be our particular printer. It might just need a tune up. The belts might not be tensioned correctly.
Oh.
So that's something that we'll need to check. But I know that one of my printing techs says that if he needs something with tight tolerances, our particular Anycubic S1 is not the printer he goes to first.
Oh, okay. Well, now I'm curious. Okay, once you guys figure it out, you'll have to let me know.
Yeah.
Bossman's asking, can I print PCTG in my home without the dangers like ABS? And I know we touched on that, but it's like, this is a very specific situation. PCTG, as far as off-gassing and VOCs, is closer to PLA, right?
Yes, it's closer to PLA. I don't know how it is relative to PLA in terms of if it is higher or lower VOC output. I would imagine that it is very low. There's no smell when we're printing with PCTG. That being said, whenever someone asks, can I print X in my home, it comes down to, okay, how particular do you want to get about microparticles from any printer and any
Sure.
any material? So it's kind of like how far down the rabbit hole of that do you want to go in terms of determining if something is quote unquote safe to be printing?
Well, I mean, usually at this point we get measurements of a material, and then we compare it to things like living next to a highway,
Right.
or spending starting your car in your garage before you leave, sort of thing. So I haven't there's been zero issues with any sort of smells. And again, it's printing right behind me. I mean, it looks beautiful.
Right.
Wait a minute. I'm printing that with default settings. So is it going to break?
It shouldn't, but it could just be, I don't know. I mean, it's not going to be as good as if it was using one of our profiles, but one of the other things. So one of the other things that we ended up changing as we were developing profiles, and this is just something where, getting a lot of customer feedback really helps us make things better. We used to have the default print bed temp set to 70 degrees Celsius on textured PEI, and textured PEI, one of the best surfaces that we print PCTG on.
Okay.
Not to say that you can't on others, but it's just the one we have the most experience with.
I mean, that's going pretty good on textured PEI right there.
And once we had more customers using PCTG, they're saying, man, I'm having a tough time with bed adhesion. The print keeps coming off the bed, or it shifts slightly, and I'm getting layer shifts. And what it came down to was that they were printing in a cooler environment than our shop is. So their overall ambient temperature was lower. And so what was working well for us in our environment, where it's, maybe 75 degrees Celsius in most of our shop, a 70 degree, or not 75
Fahrenheit,
Celsius in our
dude.
shop. Fahrenheit. Sorry, man.
Good.
That's,
oh my gosh.
Yeah, that's why I'm looking so red, Joel. I'm just so warm
right
now.
That's right.
Yeah, it's definitely not sunburn. But the ambient temperature was making a big difference in parts detaching from the print bed. Now we've upped that recommendation to 80 degrees Celsius. And when customers would reach out to us, that would be the only thing we would tell them to change. And they'd say, oh yeah, it's been rock solid for a dozen plus prints now. Just that's great. That increase in 10 degrees C.
And that doesn't, I mean, it has a higher glass transition temperature than like PLA, and so getting it from 70 to 80 isn't gonna, but you're still not approaching. What is the glass transition temperature of PCTG?
The glass transition temp is 84 degrees Celsius.
Okay, so you're under it.
Mm-hmm.
Yeah, okay, but you're close. But you're close.
Right. But that's why the 80C works better than the 70C, is because you are that much closer to where that glass transition is.
Der Dackle says PCTG has been advertised to me as PETG, but better in every way. And I think you and I have been part of the reason why that's been advertised that way. Are there use cases where someone would choose PETG over PCTG?
I think there are a couple of reasons. One is going to be the stiffness. So if you need a stiffer, more rigid part, PETG is going to be better. That's why, for example, you don't really want to be using, if you can help it, like for something like a dummy 13 model, PCTG is going to work so much better for those snap fit joints than the PETG is going to be, because it has more flex to it. It's not as stiff.
Oh, okay. I see. But then you could use then PLA or PETG or whatever for the armor, because you're not relying on that to flex.
Right. Right. And then the other reason that you would use PETG over PCTG, and this is just me being very blunt, it's less expensive. I mean, the raw material cost is less expensive. The filament itself is less expensive. I mean, you can't throw a rock without hitting a dozen, sub $10 PETG manufacturers on Alibaba. Like, that's just, I mean, that's just the fact.
It's the nature of the beast.
Yeah.
Okay.
But a lot of that heavy lifting for PETG was done 10, 15 years ago, where PCTG, there's a lot more development work that has to happen now. And I mean, we know that at some point there's going to be other filament manufacturers that are standing on standing on our shoulders. And that's totally fine. There's going to be someone that comes out with a less expensive PCTG, but good luck getting any response when you email them or call them. I mean, there's a cost to that. I think that's something that we sometimes forget about in this hobby, is that, hey, there's a person on the other side of the screen. And if you want to be able to communicate with that person, that takes time and resources. And hey, if you want a custom color of PCTG, we can do it. Yeah, it's going to take a little bit of time, but there is a cost to it. That's just the economics of it.
Yeah, I get it. I worked long ago. Well, here first. So Josh Kaiser sent me a high five for a nice Seattle latte. Thank you for that. I had to call that out because that's awesome. But also, in speaking to that, so long ago, I worked at a company that would intercept support calls and take care of them with an automated system. It would, and the goal being, it would keep people. This was, before iPhones and that level of thing. But it would keep people from reaching a human, because once a support request reached a human, it was automatically $25+ worth of cost, right?
Mm-hmm.
And so I don't think it's curious now that we have so much digital ways of communicating. It's still you digitally taking the time to reply to these things. And there is a cost to it, like a cost to your time, but also a cost for your business. And so I don't know, if someone comes at you with a PCTG question and it's not 3D-Fuel, you're going to help them.
Right. Well, and when you look at PCTG specifically, and we do quite frequently help people with printer settings and that kind of thing. And is it the best, smartest business move? Probably not. If you're looking at just the raw economics of it. I mean, there are some phone calls I get in, and I don't even know that I get in more than 10 words, and we get half an hour into it, and it's like, all right. I mean, they're telling me about really cool projects and things that they're doing, and I'm happy to listen to it, because I still love to learn. But PCTG, you look at what we're doing with the profile development. We're not being sent these printers for free by Bambu and them saying, hey, would you develop a PCTG profile for us? It's quite the opposite. And we're not doing that just for a single Bambu Lab printer model, and not just a single nozzle diameter either. Like, we have the E3D Obsidian nozzle that's sitting on my desk right now that I have a profile for that I'm working on. I know that MicroSwiss just released CHT nozzles for the A1 Mini, H2D, H2S.
Yeah.
So, I mean,
that's splitting the path, and so you're going to have to take
exactly
that into consideration.
Higher flow. But I mean, the people that are using those, they're usually printing thick layers. They're printing very high speed. So I mean, it's like a specialty tuned profile, but that takes time. And even if it's not me doing it, then I'm paying one of my employees to be doing it. And then it's not just developing the profile. It's all right, now we got to get it compiled, exported, put up on the website. And at some point, I think printers or printer companies are going to have better default PCTG profiles, and then a filament manufacturer isn't going to have to worry about buying printers and taking precious time to develop profiles. But
they still will a little bit. There's
a
always
little bit.
Nothing is ever going to replace that, but it is just like with PLA nowadays. Like every printer comes with the ability to print PLA pretty decent, right?
Right.
And so it could be that in the future, you know, PCTG becomes a PLA, and that it's just things work. I do got to call out a few.
Yeah.
Bearded Printer sent me a tenner. Awesome content. Thanks for being an advocate for innovation. And that's to you. I'll tell you what, I'll split that tenner with you, John, and I'll buy you a coffee when you come to town. How about that?
Yeah, or I mean, we'll be seeing each other at 3D Printopia
there we go.
in a short while, so that'll be
I
good.
owe you a coffee. Digital Panda sent over a tenner for a super sticker. Thanks for that. And FEP Labs Radio, awesome stream, Joel and John, great info. It's really cool that the audience here is excited about this. Like, information is good, and just having a conversation about complex topics breeds those questions that you may not have even thought of before. Now, granted, you've probably been asked a lot of stuff. When was the last time someone asked you a question regarding PCTG that you hadn't heard before?
Oh man, that I hadn't heard before.
That you hadn't heard before.
Because we get asked a lot of really good ones. Oh, here's one that's actually come up in the last 2 weeks, and it's something that we're working on. It has to do with the flame resistance, the UL94 flame resistance of PCTG, because this is a customer that is actually working to replace rotationally molded objects by 3D printing them in PCTG, but because they tend to be in like sports stadiums and public venues, they want to know what the UL94 fire rating is, and they're trying to get to a V0. It's possible it is going to affect the clarity of the material, because it's just, with that type of flame resistant additive, it affects those kinds of things.
Sure. Well, I mean, it's an additive. It's going to occlude the light, right?
Right. Exactly.
Yeah.
Exactly. So they're trying to figure out, can it be done? And if it can be done, they're talking, I sometimes forget how small 3D printing is in the world of plastics in terms of how much plastic it consumes compared to
and how much it wastes. And how much it wastes.
Yes. Yeah. I could have a whole conversation about microplastics too, and how 3D printing, not to say that there's no we can't be better. And I think the advent of all of these multi-tool head and tool changers are really going to help cut down on the amount of plastic waste from purges. Sure. But it is where 3D printing is far from the worst offender in that arena.
Yeah, I'm sorry to interrupt you, but yes, regarding plastic usage, right? It's 3D printing, like us in the community. You see, like I'm looking at hundreds of kilograms worth of printing material that I have here at the studio. And at the same time, that is a percentage of a percentage of a percentage of a percentage, right? It is literally nothing when it comes to global plastic use.
Right. Yeah.
But hold on, John. But that doesn't mean that the person using it doesn't care. And so that's where I'm really happy that we're able to have these conversations.
I agree. Yeah, because even and I mean, it also is kind of a testament to how small the filament manufacturing community is, where I think almost every company that is a brand in the US that is manufacturing 3D printed filament, we all know each other. I mean, we all kind of we all have our niches and focuses.
Here, let's see. Someone said, let me find it. 3D Jake PCTG is excellent to print. Like even you're probably friends with the people at 3D Jake, right?
I'm not that I'm not friends, but I've not had an opportunity to become friends with them. And 3D Jake, if I remember correctly, is a German company, and I believe they have their manufacturing either in Germany or Austria or somewhere in East Central Europe. I know there's a number of filament extrusion companies in Central Europe. I don't know how that all coalesced, but it's always kind of interesting how those industries develop.
It is. Well, and then so 3D Fuel obviously manufactured here in the US. Is it available in Europe, in
Not
South
it,
America, in
it's
like
available in the sense that the shipping would be very expensive, but we do not have a distribution network outside of the US.
okay,
We're starting to get more questions asked about that, especially around PCTG. No one really cares about the about the PLA side because there's manufacturers everywhere of PLA.
right?
But for something like PCTG and especially some of the colors that we have of PCTG, there's more interest. We're seeing, I think, the most international interest in Western and Central Europe,
Okay.
and a little bit of interest in Oceania, so Australia, New Zealand, that area.
Oh, well, we're 3D Printopia is coming up, and like we talked about before, your 3D-Fuel is going to be there. But like the Sanjay Mortimer Rep Festival is in the UK. Would you consider visiting or going to a non-US show to spread the
Oh
word?
yeah, yeah, absolutely would. I'm gonna be attending Formnext this year. We're not in a position to be exhibiting at Formnext in Germany,
Okay.
but I've never been to a show. I've never been to a 3D printing show in Europe. I mean, for as long as I've been doing
Oh,
this, I haven't. Things hadn't aligned in
okay.
order to do that yet.
We're going to be at Formnext, and I just to preface you, being called the largest additive manufacturing show in the world is no joke.
Okay. Yeah.
So
So
there's 4 different halls, and each hall is the longest hall you've ever seen, and there's 4 of them.
okay. Well, I mean, I'm looking forward to it.
You're going to be busy. Are you going to be there all 3-4 days?
Yep. Yeah, that's the plan. I'm getting meetings set up right now. There's some interesting equipment vendors there that I'm very interested to talk to. There's again, this kind of comes back to the 3D printing materials manufacturing catching up with other areas of plastics manufacturing where automation is really starting to make sense. So,
Oh,
and I mean, at these shows, one thing that always surprises me is just the number of things and number of companies that I have never heard of before in my life that are doing such cool stuff that I don't know how I've never heard of them before. Like I just, it's always just such a wonderful moment of
it
discovery
is.
going to those shows.
Especially when they're tangential to your industry, right?
Yeah.
Or like you're like someone you should have met a long time ago, but for some reason you never have, and then finally you do.
Yep. Yep. Yeah. And even like going to shows that are outside of your industry, but you are a consumer of what that industry makes. Going to Pack Expo, for example. So that's just a massive, I mean, they have multiple of these in the United States. I think they have like Pack Expo East and West and Central, but it's
Oh,
all about packaging. So box manufacturing and bottle manufacturing and, just stuff like that. Cause I mean, we're looking at ways to automate our packaging process. And
sure.
it's one of those like, well, I don't know what I don't know. And what better way to see and, see some of this stuff in person? Cause I mean, don't get me wrong, search can get you some things, but a lot of times the most interesting companies do not have good search engine optimization, or they don't have good content on their website, or it's like a contact us for more information. And I'm like, oh man, I don't even know what information I want. How do I
Yeah.
ask you what I don't know I need to ask?
Yeah. Well, I mean, it's good people. Good people can have really bad websites.
Oh yes. Yeah.
I think is the way you put it. A
Yep.
bad website does not mean you're a bad person,
Correct. Oh, 100%.
or an incompetent person. Pfeffers, that was a difficult one. For printing your PCTG for a transparent part, is a larger nozzle better than a smaller? Or any tweaks would you recommend compared to your stock profiles for maximum clarity? This is, I mean, obviously people have printed like transparent PETG with a big fat nozzle, really
Mhm.
slow to get those really transparent layers. Is the same concept for PCTG a thing?
Yes. Yeah. Very, very similar. In fact, I was working on specifically a transparent PCTG, like glass, optically clear profile for the Bambu X1 carbon, and then I just got sidetracked. But I mean, I'd say I got 90 to 95% of the way there in terms of having a
Wow.
profile I was really happy with, and it was from following recommendations for PETG for getting a good optically clear part.
Oh,
I
okay.
think the biggest thing I ran into was, well, two things. One is, they always advocate printing hot and slow. To our earlier point about too much heat at too slow of an extrusion rate, it can cause degradation of the PCTG.
Yeah.
You've got to be aware of that, because it is possible to print too slow, and it's possible to print too hot. Then the other challenge I had was getting the top surface layers to be just perfectly smooth, so that it would be more optically clear from more directions. Because when you have the extrusion going in the same direction, it's a lot easier. But even when you're doing your top layer, even if you have your top layers all going in the same direction, by the time it gets to the very top, getting it so that you don't have a tiny little visible ridge or depression between the extrusion widths it's challenging. So you really have to sit there and tweak the extrusion flow rate, the flow rate multiplier to really get it dialed in. And like I said, I couldn't quite get it across the finish line before I had other projects pile up.
Okay, but it should be something workable should be possible, and this person just needs to take the time. Do you have like research on your profile that you did that you can put in a blog, or is it available on your website anywhere?
It's not publicly visible anywhere. I would need to, I mean, Joel, all it would take, right, is 1 hour of time to get all of that compiled. And then it takes an hour away of time from the other things that only need an hour of time.
If this person bought some PCTG from you and had this question and emailed you, would you be able to reply?
Yes.
Okay.
And I really should just turn that reply into a blog post.
You should. Absolutely.
Yeah.
Absolutely. That's what ChatGPT is for.
Yeah. Right.
Extra Tim said that 3D Jake is an Austrian company. So
Austria.
Now you know. And this is producer David here, just making sure we all know. We are doing a live show from the FormNext event floor. And a very, very special surprise this year at FormNext. I didn't want to tease it too much, but he teased it. So, okay, we have a very, very special surprise this year. So now that I know you're going to be there, John, this is exciting. You'll have to see the surprise.
Okay. Yeah, absolutely. I'm looking forward to it.
Could be fun. This person, Raw Bear Toe. I like that. Raw Bear Toe. Great filament and content. Any plans for standard nozzle profiles for MK4S running an MMU3 and requires a standard nozzle? So you've got profiles for the Mark 4S, right?
Yes, but the stock nozzle it comes with is the high flow 0.4 millimeter nozzle. We have
that's right.
And we have the non-high flow nozzles on hand and ready to be installed and build a profile. What I would recommend, if you're able to adapt a profile, if you're comfortable adapting a profile, I would recommend starting with the profile we have for the high flow 0.4 millimeter nozzle, and then increasing the hot end temperature by 5, maybe 10 degrees C. But the way that Prusa Slicer has their dependencies set up in Prusa Slicer, once you have your head wrapped around it, it makes sense, but it's complicated. It could be clearer. I know it's intimidating. It was intimidating to me. We've actually submitted our profiles that we already have built to, we've pushed it to the Prusa Slicer GitHub repo.
Okay.
And so I'm hoping within the next week or two that those profiles will become baked into or downloadable from within Prusa Slicer to Prusa Slicer. Because let me tell you, there are some profiles on there for 3D-Fuel filaments from when the Mark II was the main printer that Prusa had and dependencies weren't a thing. And I've had some customers say, "Hey John, I tried your tough PLA profile on my Mark 4S. It's terrible." And I'm like, I know. One, we didn't develop it. A customer did and submitted it. And it was when the Mark II was the newest printer that they had. So
yeah. Let's get that fixed, man.
Yeah, we're working on it.
This person, so Lagbert, was in the chat before we went live and had some questions, but this was one of them, and I want to make sure we get to it. What's the best way to anneal PCTG? Which makes me also think of, can you anneal PCTG?
The short answer is yes, you can. I would need to do some digging, because I've worked with someone that had experience annealing PCTG. It's not a common question that comes up, and I think it's because the annealing process for PCTG takes a decent amount of time. A decent amount of time meaning like 6+ hours to do. So there's not a lot of people that find that the juice is worth the squeeze on going through the process.
Okay, that's fair. I like that. Yeah.
This would be another really good blog post once I'm able to surface that information. I would need to, so Legbert, I can find this. I would recommend you reach out to us so it creates a ticket so it doesn't just fall to the bottom of an inbox, because I will need to do quite a bit of digging through my inbox and texts and stuff to find where I have that information. But I know it's possible to do.
But this is cool though. Lagbird and others, if they reach out to you for a support request and it generates an interesting response, that gives you an opportunity for website content.
Mm-hmm. Absolutely.
And then you can say, thanks to Lagbird, we looked this up and here is some stuff.
Right.
Yeah. Oh man, let's see. Where was that? There it is up there. Check out my print. Still going. It's got some good height on it.
Yeah, that is looking good. I know I'm kind of looking through some of the comments as they're coming in, and as Aaron F. Geared, I think PS dependencies make no sense.
Here we go.
Yeah, it's like I think once you get your head wrapped around it, but even then, it's like it's so complicated because you'll have a dependency on a dependency, and then once you have, and this is not 100% unique to Prusa Slicer, because I ran into this problem before when developing profiles for a slicer that doesn't have PCTG as a default. So you need to base it off of a PETG profile.
Oh, yeah.
And then it has all of the PETG information as a dependency. And so if you export it without that PETG profile with it, then when you import it into your slicer, like when a customer imports it into a slicer, like let's say they haven't selected that exact same PETG base profile as something to even have in their slicer. Well, then it's not there for the PCTG profile to reference.
Yep.
And so I've definitely utilized ChatGPT to like create a standalone no dependency PCTG profile for a couple different things.
Well, the big thing too I know on the Mark IVs and the Core 1 platform, like I've had tremendously good a tremendous amount of good prints from these things, but in printing PCTG, that dependency really kind of kicks you, because if you don't have that dependency to PETG and you create a PCTG profile on the machine, if you load the material as PETG, because that's what it's closest to, it says when you try to print to it, we can't. Like if you use Prusa Connect to print to it, it won't, because it'll say this isn't the material that's loaded because of that whole dependency chain, and it's just it's a little complex.
You can set up a custom filament profile on your Prusa on the newer
firmwares of Prusa
printers. But I mean, again, trying to be the most helpful to the greatest number of people, not everyone knows that's even a thing that you can do. So if they download our Pro PCTG profile, then they try and print it, and they're like, well, I can't even select PCTG as a material of what I have loaded into my Prusa. So yeah.
All right.
And that changes every month, it seems. Yeah. Go ahead.
I think that, I mean, I have gotten successful prints of your PCTG on my Prusa machines. So I'm not, I wasn't stopped. There we go. I wasn't stopped from getting it, but it did take a little bit of effort to make it through. And like Aaron F. Geared has said, it makes no sense. It was a little more effort than I think I should have had to do.
And Joel, you're hardly a novice at this point.
Yeah, I don't know. I beg.
I mean, there's just so many new people that are just getting into 3D printing now. I mean, for the first time this month.
Well, look at this. And this is actually in relation to Moji's question here. So Moji 3D, good to see you. 3D-Fuel's PCTG profile for the Elegoo Centauri Carbon is perfect. Prints like butter. And this is really cool because that Centauri Carbon is priced at $299.
Yeah.
And to be able to, and it's an enclosed machine, and to be able to take what I would consider to be an advanced material and print it fine right out of the box, that really unlocks that material's ability to be democratized amongst people who might not have that technical expertise for customization.
Yeah, agreed, 100%.
Which is really cool, right? Because then if PCTG, I'm trying to think of it in a way for like education and manufacturing in the US. Producer Dave and I, we have something called the Community Manufacturing Initiative, and we're working with Experiential, and we're building it out right now. But in being able to tell people about these advanced materials, it's worthless unless they understand it and then can use it.
Right.
And so in pushing that sort of narrative, things like the PCTG profile for the Centauri Carbon, it's really enabling that the young person who likes to 3D print, it allows them to experiment with advanced materials.
Yeah, actually, and making those end use parts that are, you know.
Do you have an education discount?
We do, yes. So it is a 7.5% discount, and all you need to do is just reach out to us, and then we'll go ahead and apply it to your account. And then every time that you log into the 3D-Fuel website, it'll show that discounted pricing, and you can just go ahead and place the orders. Yeah, and we just also like do, and then tax exempt purchasing too. So I know we have a lot of school systems that that work with us, and we are able to accept purchase orders. It's not. We don't have a streamlined way to do it where someone is able to go through the normal e-commerce checkout and issue a purchase order, because, you know, you're dealing with in some cases, dealing with net 30 payment terms. And a lot of times whoever's doing the purchasing is submitting a PDF purchase order to you. So that's another area where it takes time and manual effort to, you know, to do some of those things.
It's okay. So as a small business owner, I understand. I mean, we're talking about 3D printing. I too am a small business owner in the 3D printing space. Have you found that there is any automation that you can apply to your small business that aids in the day-to-day? Yes, I asked you a question you hadn't thought of.
Yeah, there are. And I mean, it's not going to be like, oh, use ChatGPT for this. I mean, yeah, there's some things you can do with that. Honestly, having if you focus on your operational tech stack and really know how that all works. Like, Joel, there are some tools. There's some tools that I have been using for, what year is it?
I've been using 2025.
They keep on going up. They keep on going up.
They do. Yeah.
Oh, I mean, well over a decade. Like ShipStation is one that.
Okay.
I mean, I've used that. I mean, I cannot imagine having to manually type in shipping addresses. I mean, one of my first businesses, my first e-commerce business is I had a Bricklink store. So for the Lego heads out there, you'll understand this.
Oh, okay, yeah.
And every order that I processed, and I was in high school at this time, every order that I processed, I had to handwrite the label. I had to take it into the post office, and I had that many orders that were international. So having to fill out a customs form was just a nightmare. Now having something like ShipStation, where, all right, your order comes in through Shopify. That's what we use for our e-commerce platform. It automatically goes to ShipStation. Then when you ship it out, it already has all of that weight information. We have it set up in ShipStation, so it'll automatically select the right box size, I'd say 9 times out of 10. So that reduces 2 to 3 clicks for the shipping person. And it also estimates the correct weight. Again, 9 times out of 10 is correct. Saves another 2 to 3 clicks. It doesn't sound like much, but when you're adding that up over dozens or hundreds of orders a day, it's a meaningful amount of time saved.
Yeah. Oh, I agree. Well, there's tons of things, just especially with 3D printing itself and print farms, that ability to just tell 100 machines to make a single thing, and then when it's done, hey, just make it again. The amount of time it saves in the manufacturing process is wonderful. Jack in the shop, does me trying a new material to print count as education? I want to say yes, it does, but with the link in the description, they can get 10% off, right?
Yep. And this is a good point to bring up. The 7.5% doesn't stack on top of the 10%. It's kind of whatever your best discount is, that's what wins out. Same thing with quantity discounts. We offer quantity discounts starting at I think starting at 5 spools of filament, going all the way up to like 50 plus spools in an order, and that quantity discount will automatically kick in.
Okay. So was just joking, but come on, I had to put that on screen. So my buddy Chris here says, hey, John, did you cover CF and GF in PCTG? So carbon fiber and glass fiberglass. I know that there's a matte PCTG that does have the carbon fiber in it. It's a small load, but it just makes it matte. Do you put glass fiber in yours as well?
No, but we are working on a glass fiber reinforced PCTG. We're just working with a different compounder on that than we are with the carbon fiber. So the carbon fiber compounder that we're working with, they're great. I'm not going to name the name, but they focus on recycled carbon fiber, and so they're taking waste or things that would otherwise be waste from the aerospace industry, and they're able to reuse that. And because it's chopped carbon fiber, the length doesn't need to be, it just needs to be short enough so it's not jamming up the 3D printing nozzle. And
hey, that's cool.
So the matte black has 5% carbon fiber in it, and we're actually working on other matte colors as well. But it's kind of that, well, what color do we want to invest time and energy into having?
Understandable.
We'll also have I think it's going to be a 15% carbon fiber PCTG. And even the matte black with that lower 5%, it is stiffer than the virgin or the non-reinforced PCTG is. The downside to getting that increased stiffness is you don't have as much impact toughness as you do with the unreinforced.
It's just that trade-off.
It's stiffer,
right?
Exactly. Yeah. It's stiffer, so it's going to be less impact resistant.
But having the choice, though, depending on the final output, you might need something that's slightly stiffer, and you don't need the impact resistance, or you're like, nah, it's got a flex, right? So you have those options. Chris Chamberlain, will 3D-Fuel be at 3D Printopia this year? Yep. I can confirm, yes.
Yeah, looking forward to it. It's fun. It's been one of my favorite Rep Fest events. They do such a good job of organizing that event, and they've been so successful with it that this is the last year it's going to be in its current location. And
that's right.
Next year it's going to be in Philly, and from someone that has to fly in, that's going to be great, because I think the convention center is only like 10 or 15 minutes from the airport, so I won't have to deal with renting a vehicle like that. It's just nice to not have to do that. You're going to have more hotel options, more food options.
It greases the skids really well.
Yeah.
There's a couple things I wanted to bring up. So at 3D Printopia, I'm glad that Chris asked this. Is there anything that people can look forward to from 3D-Fuel that isn't announced yet?
That isn't announced. Well, yes.
Is there anything coming that's cool?
And I mean, I'm good with teasing this right now, and the only reason I can't like fully say it is because I'm still waiting on some data to come back. But we're working on, so one of the advantages of PCTG over PETG is that it has better UV resistance. But we have people that really want to have something that competes with ASA, and we don't know how the PCTG is relative to ASA in terms of UV resistance. Like, that's one thing people always bring up when they choose ASA, is its outdoor capabilities.
Yeah, and it's not, and it's the color stability that ASA gives you, right? It's not necessarily the material stability, right? It's just the color that's UV resistant, or is there mechanical properties that benefit?
It's the polymer doesn't break down. It doesn't get broken down by the UV rays and those radiations. So there is mechanical benefit to it. So if you think about like a PLA or something that's been out in the sun for
I have many, and it doesn't look like it used to.
But on the mechanical side, it is more brittle, because it basically
100%. What I'm saying is the thing has crumbled a bit.
Yep. But we're working on a UV resistant additive that should get it to surpass ASA in terms of its UV resistance.
Really?
It's been undergoing testing, like advanced weather lab testing, for the last, I think, 2 months, because we want to quantify where this is relative, not just to ASA, but also how much more UV resistant this, the super UV resistant PCTG is to our regular PCTG, but also where all three of those other materials stack up to PETG. So we can say something more definitively than just, it's better.
Yeah.
Okay. Well, so, everyone's better means something different.
So that definitive answer could be at 3D Printopia this year.
Yes, I'm hoping that the lab testing will be wrapped up by then, because I already have the additive. Like, we already have it, so we can run it. We can turn it into a product. But I'm not going to do that until I can say this is definitively where it stacks up.
That's fair. No, I'm just looking. I'm looking forward to it. Like producer David said, I am emceeing the event this year, and he's given the keynote on the build platform. So it should be really good. Jason W says, hello, John. I use a 3D printer to college to print training aids for the health department. Do you think PCTG would be more useful than HTPLA? And I want to say I think so, but I'd love to hear what you think.
I think so because of its better and broader chemical resistance than PLA, especially with sanitizing chemicals. So PCTG historically, well, one of its original intents was to be a BPA-free alternative to polycarbonate. So polycarbonate filled with BPA. Yep.
Yeah.
And PCTG is also in the same type of family as the plastic that's used to make Nalgene bottles. Like Nalgene bottles, it's a material called Triton. It's in that same spectrum, but it has an even higher yet CHDM than PCTG. But one of the other things that PCTG is used a lot for is in the medical device industry because it is so chemically resistant and it is skin safe and it is, FDA approved for food contact. I mean, we don't call it a food safe filament just because we don't like calling something food safe because 3D printing and food safeness have had a complicated history.
Just stay away from it. Just stay away from anything around that.
Yeah. But yeah, I think it would be more useful. And I guess a downside relative to a PLA that PCTG has is generally speaking, you can't push the volumetric output as fast as you can with as broad of a temperature range as you can with PLA. So PLA, like your volumetric max, I think for a lot of the defaults in I'm just going to use Bambu Studio, is like 20 to 21 millimeters cubed per second. With PCTG, it's more like 10 to 12 millimeters cubed per second, assuming everything else, your nozzle diameter, all of that is the same.
Oh, okay.
So cool.
This has been fun, John. I want to sort of wrap some things up here because I know you have some things going on, and obviously, the work is never done. We're both small business owners. Like, we wear many hats.
All the hats.
But what I want to do is give you an opportunity to address the audience at this point and just make the case for PCTG and why they should look at you.
Yeah, PRO PCTG is a really, really good functional 3D printing material. It's not necessarily going to be just because you have a hammer doesn't mean everything becomes a nail. Same thing with PCTG. But for those projects where it is a nail and you have a hammer, it is a really, really darn good hammer. So for functional parts, for end use parts that are going to need to be outdoors and really take a beating, PCTG is a fantastic material. We have it available now in, I believe it's 45 colors. And if you're trying to figure out, well, what color of PCTG is right for me, we just launched a tool on our website where you can upload an image. It will identify the 5 most prominent colors in that image, and then we'll match it with the closest 3D-Fuel color to that color that was identified in the photo. So really good color selection, cool, man. Really good material. Yeah.
Hey, just an idea. At 3D Printopia, do you think live people could come by your booth with a photo or with a picture, and then you could at that time tell them the 5 colors that are in it and give them the links to your material?
Yeah, we certainly can. I think it makes a great demonstration. The great thing about the tool that we have is it runs just as well on your phone as it does on a desktop browser. So you could take a picture of something. Now there's all the color science and stuff, right? Like, hey, a picture in one lighting situation is going to be different than a color of a physical object in another lighting situation, and different screens display things differently. But it works really well.
Well, and it's matching against 45, right? Your 45 colors that you offer this in. It's not like it's trying to match a Mimaki style 3D printer.
Right, exactly.
Right? There's 45 colors that you're offering, and it's going to pick colors out of there to match it. I'll try it out later today.
Awesome.
And everybody watching, 10% off your 3D-Fuel purchase. There's a link in the description. I highly suggest you go click it and go shopping because John is awesome. Dude, thanks for joining me, man. This was a lot of fun.
Yeah, thanks for having me, Joel. It was good, really good time.
I think the response has been great. Why don't we circle back maybe this springtime, just see where PCTG is, see how 3D-Fuel is doing, and kind of talk about it again.
All right, sounds good. Thanks again, Joel.
Yeah, no problem, dude. Well, I will let you go. hang out for a sec, and then I'll say goodbye to the audience here. Thanks for watching. Obviously, we had a good time talking about this. If you did make it this far in the stream, I appreciate you. Have a great rest of your day. Hug each other more. And as always, high five. There we go. That was good. That was good. That was good.